Hello, it's Mr. Day. Today we're going to work on scientific and standard notation as well as powers and exponents. If you're at Larchmont, then this is in the review packet, getting ready for the Unit 8 test. So first of all, we've got standard notation. Big numbers or small numbers, huge numbers right here, in the millions, billions, and trillions, and very, very small numbers that can measure things like way deep inside of your cells in your body. So what we want to do is represent these in a way that is less bulky. So what we do is we use science. Now this one here, on a giant number, huge number, there are 20 zeros. If you count them, you can trust me, there are. So we can, if we go all the way along, how far do we have to go to make it 7.6? We've got to go 3, 6, 9, 12, 15, 18, 19, 20, 21 spots. So we're going to write 7.6 times 10 to the 21 as our answer for our scientific notation. And that's how these things work together. If we move along to 2C, I'm skipping a couple questions. Then we're going now from scientific notation to standard notation. And in this case, we want to go, because it's a negative exponent, we're going to go left. We're going to get a smaller number, okay? And I'm going to put 2C here as well. And we're going now from, we have the 6.8 gets moved to 68, but this gets moved over 1, 2, 3. So we're going to have to add 2 zeros here, right? And then we're going to get 0.0068, a very small number. And to check it, we go, okay, well, what would it get us to 6.8? 1, 2, 3 spots over. So that's all we have to do. Going to D, 2D. This number is big. Why? We don't have a negative exponent, positive exponent only. We have to go over 8 spots from there. So that's 3 of them. We've got to go over. We've got to add zeros now to make this happen. So 4, 7, 3, 5. We've got to add some zeros. 5 zeros. Now, we want to make this a little bit easier to manage, but basically it's like this with commas and all that good stuff. That's what we've got. Big number, and that's how we manage it. Let's double check. In order to double check, we've got to see how far we went. 1, 2, 3, 4, 5, 6, 7, 8. Always do the double check, guys. That's the key to being a good mathematician. Double check your work. Be humble. Double check your work. Over here, 4A, this question asks you which one of these do we need to, which one of these is already in scientific notation and what do we need to do to make it go into scientific notation if it's not. This one's already there. Why? How do we know? Because this right here, 2.7, is already in the form between 1 and 10. So we're good. This one is check. It's scientific notation. This one is not. We need to move it over 1 and we get 2.767 times 10 to the, what did we do now? Think about it. We got a big number, 27, and we made it smaller. So we have to compensate, because we went smaller, we have to compensate by making this bigger. The 2 went to the 3, the 27 went to 2.7. That's a reasoning way to think about it, and that's very important to put that reasoning into play. So this now is in scientific notation. This over here, not in scientific notation, right? But we can put it that way by putting it, by moving this over 1. What we did here is we took a small number and now we're making it bigger. We're making it 3.8. So 0.38 became 3.8. And there, in order to compensate for that, we have to therefore change this. We're making this small number bigger. We have to make that small number smaller. So it's -5. Okay, so think about it. This is now, we're compensating this. This is the same thing as this, but it's written in a different format. What is that format? It's scientific notation. This is a tricky question. I wouldn't say it's a trick question, but some students have problems with this. This is already in scientific notation. Why? This number is between 1 and 10. Where's the decimal point, people ask? Well, there it is. If you prefer to write it this way, you can. It makes it a little simpler to see. It's 5.0, so we're good. That's scientific and standard notation, understanding and going back and forth from the differences between the two. Of course, why is it called scientific notation? Think about it. Who uses these big and small numbers? Not you or I in most daily use. We don't use trillions and billions. zillions of light years. Who talks about light years and huge amounts of numbers? That would be obviously astronomers, for instance, outer space, the galaxies. Those kind of measurements are done with scientific notation. And conversely, when people are, with microscopes, are looking into the cells in your hand or in your body, they're looking at sort of very, 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 very tiny, small, scientifically small numbers. And that's why they use these notation, scientific notation. All right, let's move to the next subject.